Good morning, good afternoon or good evening to our SUSECON 2022 session on SUSE High Availability for SAP. And we're going to present a couple of recent findings and examples from our projects on-premise and in the public cloud. The topics we're going to talk about are the srHook, which we strongly believe is mandatory for all our use cases. Then we're going to talk about the large HANA scale-out clusters, especially for business warehouse use cases. Afterwards, we are, as we've seen the need recently, we're going to talk about bringing existing HANA system replication setups, be it scale-up or scale-out, under the control of a SUSE cluster. My name is Thomas Korber. I'm a Linux architect at B1 Systems, and I've been working for many years in the environment of high availability and SAP, and I've worked a lot together with my colleague Lars Pinne, who is going to introduce himself in a couple of seconds.
Hello, my name is Lars Pinne. I'm working with the SUSE team at SAP Linux Lab, and I'm now going to discuss or explain the need for srHook cluster attribute. Why is the srHook mandatory? So we have two cluster attributes representing the HANA system replication status. One is the sync state and the other one is the srHook. Both are representing the HANA system replication status, but they are different. They are different in two aspects. First of all, the sync state is polled by the SUSE resource agent in a regular interval. And the sync state is a cluster-wide attribute which is not site-aware. On the other hand, the srHook attribute is based on the HANA event as a connection change. That means this attribute is written by HANA actively towards the cluster. And this attribute can distinguish between sites, so it is site-aware. Another aspect is, or not another aspect, a consequence of the polling versus the HANA event is that the sync state attribute might get lost in certain circumstances. One case, in rare cases, where the sync state can not be fetched by the SUSE cluster is when an error situation occurs while the system replication network is broken and the cluster network is still intact. Then we can see here on this diagram there is a short phase where the cluster may get a wrong system replication status by polling this attribute. On the other hand, even in this situation, the srHook will be raised or written by the HANA with the correct value on a certain time. So, what does it mean at the end? The scale-up setup needs the srHook state to be safe in any case. Another side effect is that the scale-up system replication may benefit from srHook because a monitor operation always can time out. That means if a monitor times out while the srHook, while the sync state is still SOK, then the cluster may get a false failed value. And besides that, the srHook always is multi-site aware, whereas the sync state is not. And finally, if you look at the scale-out setup, scale-out always needs the srHook attribute. The sync state does not work with scale-out at all. So, conclusion, srHook is mandatory.
The next topic we would like to talk about is our findings and recommendations for running SUSE HA scale-out clusters in connection with business warehouse systems and HANA. Business warehouse implies that in comparison to ERP HANA systems, you have quite high number of nodes and comparatively small nodes as far as memory is concerned, which means that you not only have many HANA nodes, but that you also have, of course, many cluster nodes. And this implies a couple of tweaks that you need to think about, and this is what I'm going to talk about in the next couple of minutes. HANA scale-out systems basically consists of a number of HANA nodes, and of course, as we have a system replication in between our two data centers or availability zones, this implies that we have the same number of HANA nodes in the other data center or availability zone, and that also implies that we have a network connection in between these two data centers, which is used for the cluster communication of ChorusLink, and which is used for the HANA system replication, which consists of a number of connections depending on the number of tenants, and of course we have connections for each of the HANA services themselves. And Lars talked about the srHook and SOK and sfail, which means the state of the system replication as it appears in the cluster. And the sum of all good HANA system replication channels determines the state of the status of the cluster system replication. So if one of the HANA system replications fails for one tenant, for example, then the cluster deems the whole system replication has failed. As far as, once again, the srHook is concerned, it's absolutely mandatory to use it. There is no way around it, because simply depending on the resource agents to determine the system replication state is simply not enough. You need the way from HANA towards the cluster to make HANA more or less write a service, a system replication state change into the cluster right away. There is absolutely no way around that. Second thing is that it's also more or less mandatory to tweak the cluster IPC limit and to tweak the ChorusLink consensus timeouts, because the defaults are way too small, and it's quite a clever idea to have ChorusLink set the consensus timeout itself, because this is determined by the number of nodes. We'll come to that in a second. Next important thing is that it doesn't make too much sense to bother with setting up standby nodes for HANA host auto failover at all, because having a failover inside HANA takes so much longer than just a simple takeover to the other data center, and that's what we really bother about, because we want to have a downtime that is as small as possible, and using host auto failover simply takes too long. Then it is of course always a good idea to use the most recent releases of the two resource agents, SAP HANA Controller and SAP HANA Topology for HANA Scale-Out, because even if these agents are or always have been quite good, there are always things to improve, and especially in recent releases, the situation that when the HANA master name server is down or has failed, then more recent versions of these resource agents can handle taking down the rest of HANA much more efficiently. when it comes to the CoroSync consensus timeout, the thing to do here is simply to comment the consensus line in the token section of CoroSync conf, and then CoroSync will, as I said, calculate a suitable value automatically. In this example with 27 nodes, we will see that although 36,000 is the recommended value, CoroSync itself believes that increasing this timeout considerably makes a lot more sense. And why is that so important? Because under certain situations when there are many nodes joining or leaving the cluster, for example, if you start CoroSync after a maintenance or so on all 27 nodes in parallel, then this is very likely to fail, and setting this to something considerably higher or even automatically helps dramatically. Next thing I've mentioned in the introduction of this topic is the cluster IPC limit. The default limit for inter-process communication channels is 500, and this is for many nodes and many resources simply not enough. The formula to calculate this is the number of resources, which in this example is 20 nodes times 2 resource agents for HANA plus for other resources like load balancers or virtual IPs and the like, or Stonit resources. All of this multiplied with the number of all nodes, which is in this case 27. This results in a value of 1512, and we just add a little on top of this and end up in this example with 1536. This will also help dramatically in basically cluster operations where things go a lot in parallel, which means that things will go smoother and things simply will not block for quite a long time, which will also again lead to resource failures and will lead to unwanted reactions of the cluster. The next thing that always in the cloud makes at some point in time some trouble is NFS. As we all know, HANA Shared is in a scalar cluster usually mounted on NFS, which means that the environment of SID-IDM is on NFS, which means that all log files of HANA are written to NFS, that the whole tool set and the Python environment of HANA is on NFS, which means that we always need to know that the NFS share, one NFS share of course on each side, has to be available all the time, and we need to know whether it's not available. This means that we need some mechanism to tell the cluster that the NFS share is gone. It's a lot better that we have a known dead NFS than a unresponsive NFS which we do not know anything about. This means that we need to add a couple of things to the cluster, which will make sure that we do not have unwanted things like SLA breaches, because unresponsive NFS always leads to dramatically slower reactions of the cluster, because the whole tool set the cluster uses is of course the tool set that HANA uses, and all of this is sits on NFS. So this will simply yield a huge number of unwanted reactions and timeouts being hit, and it takes ages until the cluster is, if at all, able to do a failover. The thing to do is to have a file system resource clone inside the cluster that does nothing else than a bind mount on to the NFS share. The important thing here is to use OCF check level 20 for the monitor operation. That means that this file system resource agent will try to actually write something onto the NFS share. It will not only read, or if you don't set this at all, only check proc mounts. And the second thing that you have to do is to use the switch on fail is fence, because then whenever the NFS share is not writable or accessible anymore, then the cluster will initiate a fencing operation, and this will very soon end in a takeover of HANA, and then the outage is as small as it can be. Good. The last topic we want to talk about is on how to get a existing HANA system replication system under the control of a SUSE HA cluster. The procedure is valid for 2-node scale up and multi-node scale out HANA system replication clusters. It is also valid for transforming or converting a existing HANA scale up into a HANA scale out cluster, which you sometimes need for different purposes. And the idea behind this comes from recent requests and recent projects, because there are people around that want to convert their existing systems into a system with a SUSE HA cluster around that, and this is why we had a look into this. The procedure has a couple of advantages really, because you only need a very short maintenance window, and you don't even really need to take your HANA down. So this can be done more or less with the HANA up and running. It takes only a couple of steps. The complete configuration and the complete procedure can be prepared in advance, which is quite an important thing. As important is that you can automate it with your preferred config management system, like Salt or Ansible, whatever you use. I've already mentioned that this works for HANA scale up and scale out, and that you can even convert a scale up to a scale out system. What has to be done? Of course, you need to make sure that your HANA is fine, that the HANA system replication is fine. Of course, you need to prepare your SUSE operating system with the necessary repositories, and of course you have to install all the packages and patterns necessary for running a SUSE HA cluster. If you use SUSE Linux Enterprise for SAP applications, then you will most likely have these repositories already on the systems, and you will simply need to install the patterns. If you want to transform a HANA scale out system with system replication into a system that is under SUSE HA cluster control, then you will also need to prepare a majority maker, the small node that makes all the cluster nodes a odd number, and this node is needed for quorum purposes, and you will not get around preparing this node. Then you can prepare in advance and distribute, of course, your chorusing configuration. You can prepare your fencing infrastructure, and you can prepare your pacemaker cluster config, which is uploaded into the cluster with one single command. If you want to know what has to go in there, then please have a look at the SUSE best practices guides on HANA and on the SUSE HA clusters, where we'll always find the most recent versions of cluster configurations, of do's and don'ts, and so on. One very important step, of course, is to not make the cluster react immediately on the newly uploaded cluster configuration, which means that the cluster has to be set to maintenance mode. This is mandatory. If you don't do that, then the whole procedure will not work. And it is also a very good idea to put the resource that controls the multi-state primitive of HANA, which is SAP HANA controller. Make sure that you put the multi-state resource that references to it into its maintenance mode of its own. This is also a very important step. If you don't do that, the whole procedure will not work. Then, if that is all prepared and set up, then you can actually do the work and make the cluster control your whole database plus the system replication. The steps have to be done one by one, and it's also more or less mandatory to always check a couple of states, which includes the cluster, which includes whether the cluster is in transition, which is it doing something at the moment or not. It's always a good idea to check the HANA states themselves. I'm going to show the respective commands on the next slide. The idea is that whenever you can see an asterisk, just go to the next slide, do the commands that are prepared there, and then do the next step. So, first things first, you will have to start the cluster services on every node, and please do not forget the majority maker. Then you have to upload your prepared CRM config. Before that, of course, make sure that the SAD and the HANA instance number is correct. Then at this point, please double check whether all cluster nodes are there, whether all are online. If one is missing, then do not proceed. Make sure that all your cluster nodes are online, and then check your HANA if the service is fine and if HANA system replication is fine. Then and only then you can remove the cluster-wide maintenance mode. Then again do your checks. Afterwards, it's very important that you do a CRM resource refresh on the multi-state resource that controls the HANA database, which means that you do a CRM resource refresh on the multi-state resource that includes the SAP HANA controller resource. Please do not use CRM resource cleanup anymore, although it still works in /12 and has been widely used. The more modern version of this is CRM resource refresh, and this is the only one that continues to work on /15 and later. The same is valid for CRM resource manage. The new thing that we are using on /15 is CRM resource maintenance. Right, and once that is done and HANA is still fine and the system replication is still fine, then we are removing the maintenance from the multi-state resource. Then we are going to do our final checks on HANA and the system replication. and the cluster state, and once that is done, we are through, and then you have a SUSE HA cluster that controls 2 availability zones with your HANA nodes in there, and a majority maker, and then you're done and you're fine.
So, thank you, Thomas. What can we take away? What can we take with from this session? First of all, there is a lot of more detailed information available. Coming with a product, we have man pages installed, and of course we have web pages with knowledge base articles, setup guides, and lots more information. Coming back to the 3 topics we have discussed today, the HRDR provider hook script for writing the srHook attribute is more or less mandatory in all cases and might become formally mandatory in the future. For large scale out clusters, corrosing consensus and pacemaker IPC settings need adaptations for large scale out clusters. Asset takeover in scale out clusters is faster than host auto failover inside the HANA, so it's for this BW kind of systems recommended to not use standby nodes. If you deal with HANA clusters or with SUSE H8 for HANA, it's always a good idea to check the status of the system, of the cluster and the HANA before doing anything with the cluster, and after you have done something to make sure the HANA and the cluster is in the state you expect it to be. If you end a maintenance procedure with the SUSE cluster, always do resource refresh to let the cluster update all the information that is needed for managing the resources. It is possible to install an HA cluster on top of an already running HANA system without downtime of the application if you follow the right procedure. If unsure, of course, you can ask for help with SUSE and B1 systems. That's it. Thank you.